All right, so while everybody's getting in, please remember to type something in the group chat so that we have a nice, neat little record. So So last time we were talking about this new stuff dealing with the measures of central tendency. So the mean, median, and mode of a set of data. The mean, also called the average, is found by adding all of them up and adding up all of the numbers in the data set, dividing by the number of numbers. The median is just the middle of the set of numbers when they are listed in order. And if there are an even number of pieces of data, then we take the middle two numbers and we average them. And then the mode of a set of numbers is the number that occurs most frequently. So these three different values tell us a lot about the data set that we're talking about. So let's do an example, kind of continuing on from last time, and look at what kinds of things we can tell from these different measures of central tendency. All right. So consider 1 pound weights placed on a seesaw marked with the number line. If the weights are placed at 3, 5, 5, 8, and 9, where should the fulcrum be placed in order for the seesaw to be balanced? So for those not used to the term, fulcrum is just a fancy word that means the point of rotation. So if anyone's ever seen a seesaw, it's just the point where it's bracketed in the middle, where the log or the piece of wood rotates around. So we're talking about 3, 5, 5, 8, and 9. So it turns out that the mean of these is where we're supposed to put this in order to balance it. So let's look at this for a second. So we have our number line, 2, 3, 4, 5, 6, 7, 8, 9. So we have one block on 3, and we've got 2 blocks on 5, 1 block on 8. No, it's too big. And 1 block on 9. So just looking at this, where do we think the mean might be? So if we put our fulcrum right here, what's going to happen?
Say that one more time.
So if we put the middle of the seesaw right here, so that the top bar can rotate around this point. So again, the fulcrum is if you have a seesaw, fulcrum is that point. So this thing can teeter, or this is what I grew up calling it, a teeter-totter. So it can go back and forth over that point. But we want the seesaw to be balanced. So if we put the fulcrum right here, well, we've got one weight on this side and two on this side. So that's not going to do us any good, because this side is going to weigh it down.
You got to be on the 6.
Got to be on the 6. I think I agree. So learn some stuff about physics today. If we put this right here, well, now we've got 3 pounds over here and 2 over here. But why does it balance right there?
Because it's in the middle. Right?
So you're right that it's in the middle of the numbers, 3, 4, 5, 7, 8, 9.
And that's the only number it could be on where it's like closest to the both sides having the same weight.
So part of it is about the same weight. You're correct. But they don't have the same weight. So this one has 3 pounds and this one has 2. The difference comes because these weights are close to this point and these two are far away. If anyone's ever, I imagine most people are able to pick up a broom, right? It's not terribly hard, even one-handed, maybe even just with 2 fingers. You can pick up a broom, no big deal. But if you've ever tried to hold a broom in your hand at the very end like this and then tilt it up, it is amazingly difficult. And it's because it's not just about how much weight there is, but it's about how far away it is from the point you're trying to rotate. And that fact is what makes it the mean or the average. So let's check to see if this is actually the average. If you add up all of these numbers, what do you get?
30.
Yeah, so 5 and 5 is 10. 3 and 8 is 11. 11 and 9 is 20, so you get 30. And how many numbers are there? What?
6. I mean 5.
There you go. Yeah. So 30 over 5, and you get 6. So this is kind of where we ended up last time. We talked about in the data sets. We'll share this. So in the 2 data sets we had, one of them, the mean was skewed because of the outlier of 155. So that was, and this one we were talking about the movie times, is the mean was 102 and the median was 93. So the mean was so far away from that median because of this guy right here. So it's not just the fact that there was one other number, it's how far he was away from everybody else. And that's what happens with this one, is these 2 guys, because they're very far away from this, they pull the mean closer really hard this way. So these three over here don't pull as hard to the left because they're close. This is another reason why if you've ever tried to open up a door, where do you push or pull on a door when you open it or close it, I guess?
The middle.
So you could, but you have a door.
You open it, comes towards you. Right?
So it's the same reason, it's actually a big reason why we put the door handle right here. It's because it's easier to push a door open right here than it is to push it close to the hinge. Next time you go to a door, especially like a heavy one, try and open it by pushing it next to the hinge and see how hard it is. It's pretty tough. But if you push it out here, it's actually pretty easy. And so keep that in mind if you're ever trying to block a door to prevent someone from getting to you. Don't push it in the middle. Push it, stand toward the edge of it, because you have more power against the mean the further you are away from the middle. So, little life advice for you. Okay. So, let's continue on. With 10.3. So we've talked about measures of central tendency. And we have this idea of, sorry, I'm keeping my notes going, of looking at the data, some numbers that try to take the data and kind of shrink it down into a couple helpful little tidbits. But another way of looking at data is measures of position. So where a specific data point exists within the entire set of data. So so we have quartiles. This is the starting point. So if we take our data and we divide it up into different zones, we're going to divide this data up into 4 parts. So if we divide data into 4 parts, the numbers that form the divisions are called the quartiles. So we often notate these in the following way. The first quartile is the number greater than, I think it's supposed to say or equal to, 25% of the data. Second quartile is the number greater than 50% of the data. Third quartile, number greater than 75% of the data. So this is kind of a weird way of thinking about it. But because you would think you're dividing it into 4 pieces, why are there not 4 quartiles? Well, because it's how these things are defined. So the quartiles, Q1 and Q3, are calculated as the medians of the first half and second half of the data. In finding these quartiles, if there's an odd number of values in the data set, we include the median in the halves. This will be demonstrated in some examples. All right. So find the 3 quartiles for the data set 8, 9, 10, 2, 5, 3, 7, 12, 15. First thing we got to do is we got to order it. So what is the lowest number?
2,
2. Okay, what's
3,
2, 3,
5, 7, 8, 9, 10, 12, 15.
Very nice. All right, so 2, 3, 5, 7, 8, 9, 10, 12, and 15. Okay. So my stop share button. So first thing we do is we figure out what is the median of this data set.
8.
8. Yeah, so 1, 2, 3, 4 on this side, 1, 2, 3, 4 on this side. So 8, the median.
Who added it up already?
Added it up.
You got to add it up next. Add all the numbers up.
We're not doing the mean and mode this time.
Okay. Okay.
Yeah, so we're talking about something a little bit different, but it does deal with median that we talked about last time. But yeah,
Okay.
so
My bad.
yeah, if someone had added it up already, that'd be pretty quick. You're definitely right on that one. So the median is just the middle number. Okay. Now remember, the median of the whole data set is what's called the second quartile, or Q2. Okay. Actually, let's do this in red. Okay. Now to find Q1 and Q3, we have to divide the data set in half. But when we divide it in half, we have to look at how many numbers are there. There's an odd number of things. There's 9 of them. So what we have to do is we include the median in both sets. So the first half of data, let's use is this. And then the second half of data is this. So we've got the first and second half. Remember, you include the median if there's an odd number of total terms. So Q1
$12.50.
I'm sorry?
12.50.
0.50?
I mean 0.5, I'm sorry. And it you have to add 8, 7, 5, 3, and 2.
So that's the mean again. This
Would
one,
it be 5?
yeah, it's going to be 5. So what we do is we find the median of both sides.
So we're okay.
So the median of this one is, there's 2 on this side, 2 on this side. So the median here is 5.
Okay, the median on the other side would be 10.
Yeah.
All right, my bad.
So no, you're fine. No, I would rather have attempts trying to figure it out than just nothing. Because it's likely that other people have similar questions or issues. They're just not as brave to interact. So keep that that mindset. But you're exactly right. 10 is the median of this. We've got 2 here, 2 here. So this is how we find the quartiles. So this is, the idea is the first quartile, second quartile, third quartile. You want to say that there's a fourth quartile, but it's not exactly set up like that. The idea is you want to find the number that is bigger than the first quarter of the items, the number that's bigger than the second quarter of the items, or 50% of them, and the number that's bigger than the third quarter of the items. If we continued that on, what would
15?
Q4 be?
15? 15?
That's the best possible answer you could give, but it doesn't actually follow what we were talking about, because 15 is the number that's just below the fourth quartile. So remember, the fourth quartile would be the number that is bigger than 100% of the numbers. So it's the number after 15. But we don't have that, right? So this is why it doesn't make sense to talk about Q4, is because it's
non-existent.
Yeah, it's outside of the data set. But the 15 is as close to a real answer as you could get, but even then it doesn't really follow what we were kind of going for. So that's why the question doesn't really make any sense. But this is where we're at. So Q1, Q2, and Q3 are the boundaries of the different quadrants you could think about. So, but good stuff, good stuff. So let's try for this data set. So what's the smallest number?
10.
So 10.
12. Oh, 2 10s. 2 10s.
2 10s, yeah.
A 12. You got the 12?
Yep, got the 12.
2 14s.
14.
Twice.
Yep.
15. 16. 3 17s. 1 18. And then a 19.
19. All right, very good. So let's first find the median Q2. So what is the median?
15, 16.
Yeah, so it's 15 and 16. So the median is the average of those two. So 15 plus 16 over 2. And this one's dead. Got to go to the store and get new markers. So equals 15.5. All right. So now we can divide this up into our two sets, but since there's an even number, we have a nice clean split. So how many numbers are there in this one?
6.
6. Yeah. So that means this quartile is this one and this one. So the same is true over here. So there's 6 of them. The quartile is this one and this one. So Q1 equals 12 plus 14 over 2 equals what?
$13.
Very good, 13. And Q3 what is 17 plus 17 over 2? So this one's easier than that one.
34, isn't it?
What?
And then divided by 2.
So you could do that, but what is the average of two things that are the same?
Itself, right?
Yeah. Yeah, so the average of two things, if everybody scored 100 on the test, then the average test would be 100. So 17. You could just, you don't even have to plug anything in and do that really. You can just say, hey, the average of something and itself is itself. So this is quartiles for that data set. All right. So let's continue on. So this idea of breaking a data set up into different pieces it is something that is very helpful, but quartiles are not always the most helpful. So if we generalize this same idea and break it into 100 parts instead of just 4, we get much better information. So a percentile is a division of data into 100 parts. Just like we were talking about percents, percent means divided into 100. So the number given as a percentile means that the data value is greater than that percentage of the data. For example, a student who scores in the 63rd percentile on the ACT means that 63% of ACT scores are less than that student's. So it means that you did better than 63% of people. And the way we calculate percentile, but there are different methods, but we adopt the following formula to determine percentile. B equals N times P over 100, or P equals 100 over N times B. B is the number of items falling below the pth percentile, N is the number of data items, and P is the numeric portion of the percentage for the pth percentile. So there's a lot of business that kind of goes into this definition, but it's actually easier to understand when you calculate it than when you actually do it. So B is the number of items below a value in the list. So meaning that the next item, one higher than B, is chosen to represent that percentile. When solving for B, we round down to the nearest integer if we get a decimal. If we get an integer value for B, then we use that value as the number below the percentile. I'm putting B in as a value and solving for P, always round up to the nearest integer for P. So lots of silliness, but let's look at it this way. So consider the following data on ACT scores. What is the value of the 10th percentile? Okay. So looking at our equation, P is 100 over N times B. So, hold on. How many total items are in this list?
Mhm.
25.
I'm sorry?
25.
25, yep. Okay, so if we take our equation, B equals N times P over 100. So N is the number of items in the list, and you just said it's 25. And what percentile do we want to know about? We said, what is the value of the 10th percentile? So P equals 10. We plug those in. So we have 25 times 10 over 100. What is that? So this gives us 2.5.
Where you get 10 from again?
So 10 is the percentile. So we're talking about the 10th percentile.
Okay, yes, sir.
N is the number of total items. So that means the 2.5 item is the 10th percentile. So we round down. So 2 below. So what number as is the third in the list? We're probably about to get cut off. So what value is third in the list? So it is 17. Because it's the third one in the list.